Well, I guess let's do this then.
Let's
So
do it.
everyone feels good with p hats now? It's just a fraction, x over n. Cool. So do you all think you can start number one?
I guess I don't understand, like, how are we gonna know when to use p hat and when, like, it'll say a sample, but I just don't get, like, the wording and stuff looks so similar to me with the two, like 8.1 and 8.2 with the samples and then the probabilities.
That is the whole battle for chapters 9, 10, and 11 is which thing are we working with? So that's a great question. Um, let's highlight all the words that tell us which is which. So let's see, we got a random sample of 100 students. I'll tell you what I'll do. I haven't done this in a long time, is how I read these things. I know that this is n equals 100. It's a random sample. That's the sample size. Ooh, a population of 7.8 million. I know capital N is equal to 7.8 million. That's the population, said population. Okay. Part-time college students US, for which the overall, here's the key word. This says we are working with a p hat proportion. And then the other clue is that we have a 0.6 here. Anytime you have a percentage for your data value or for your statistic, you know it's a proportion. So that's one of your other clues. Let's see. Let's look at another problem. Here we go. Number 2. So a dog groomer sees 38 dogs. All right, that's n, lowercase n. That's her sample size. In one very busy day, she realizes that 12 of the dogs were laboratory retrievers. Okay, that's part of the sample, right? So of the 38, 12 of them were this particular type of dog. That means this is X. Oh, shoot, I'm answering the question for you. Whoops.
That's okay.
So that's the other clue for we're working with a p hat or a proportion, is if we give you the size of the sample and then a certain number of that sample that fit a characteristic. Okay, let's do one more. In a recent year, 23.3% of all Americans smoke cigarettes. Notice this is a percentage of a population. That's P. So percents and proportions. Now, if we go back to the 8.1 stuff and compare, and then when you do the chapter review, it's all mixed together, so you get to see all of it. Here, notice, let's see, here's a problem. It says, we see the word mean in the problem and standard deviation in there, and then sample size. Oops, let's go back one more, find one more question. Here's another one. Oh, again, the word mean and standard deviation, and then sample size. So that's your key. If it says a mean and a standard deviation, you know you're working with the mean. If it says a percent, a proportion, an amount out of the number given, out of the total, then you know you're working with the proportion. Okay, so do y'all think you can do number one, or do you need a little more reminder to get started? Oh, good, good. Don't worry, you're going to get tons of practice, because chapter 9, we do all of this with confidence intervals. In chapter 10, we do all of this with hypothesis testing. And then chapter 11, we do it again with 2 groups. So by the end, you're going to be an expert at this. You won't have a problem at all. But when you first see it, I totally get it. Super tricky to keep track of which is which. Well, let's do 5 minutes, and you all see if you can't do A. I'll give you the one hint you should have here. I'm looking for C1, C2, and C3, and how those 3 things are satisfied. And then here's a stat crunch thing for D. So I'll get mine loaded up. But try this. We'll do 5 minutes, see how it goes.
Eric, the question came up last night. They were obviously a lot of people had candy, but they were the fun size ones. They ask if they put like 4 bags together.
I don't know the difference.
Yeah, I said that some of the instructors used to make them take a picture of their bag.
I mean, it says in the, it doesn't matter.
Okay, I said I
yeah.
don't think it will matter as long as
Nope.
you're like, we don't want a fun size bag because there's not enough in the sample.
Right. And
So-
even then, you can still do the problem. It's just you shouldn't.
Right. It's just your results are not
Right.
going to be as good. Yeah. Okay.
Yeah. Yeah, that's I agree. I'll say
So
that
you
again
guys,
today.
if you have Skittles and M&Ms, then take them. I don't know. I know a lot of you guys probably don't have kids, but a lot of people in our night class have kids, and they're like, we're rating our kids candy for Skittles and M&Ms. But remember that you will need to get a bag of, not a huge bag, like a grocery aisle bag size of M&Ms and Skittles. It doesn't matter on the M&Ms if they're like peanut, whatever.
Yeah. You're,
Is this for tomorrow or next week?
No,
let's see.
I think
I'll
it's
pull it up.
actually you have like an assignment for that where you put in your data now. I noticed that.
Yeah, it's
It's
the chapter 9 something.
it might be like next week
So
or the week after. So you use that data for the projects for 9, 10, and 11. Don't you love, Eric, how they put this on the like all these announcements at the front of our Canvas every time you log in?
I'm sure we can move them, but I don't know how.
I don't know how either. I'm like, every time I'm like,
I'm not going to that
and
class.
I'm not going to, and me neither. I'm like, I feel like I've sent all this stuff and I'm like, not, there it is.
So it's right here.
So
what
it's
you're,
due November 13th.
and what you're doing, well, we might as well just talk about it real fast, is you're buying those things, and here's where you're supposed to put the pictures. It's okay. And then this, all you're doing is counting them. How many orange in the bag, how many total in the bag.
So if you get Skittles, make sure you don't get like the like all berry kind or something. You want to get the regular Skittles that have like all the colors.
And then so to connect, to know if it's if you don't have enough in your bags, this condition has to be met.
Hey, I just jumped on. Can you back
Okay.
up just a little bit?
Yeah.
So I know about, we have to buy M&Ms and Skittles.
Yep, that's all we really were talking about.
All right, then keep going.
It's due, the candy that you want to have is by, that's what we were seeing, by November 13th.
So yeah, not coming Sunday, but the following one. And then you're going to use this data for your chapter 9. There's another project for chapter 9 and chapter 10 and chapter 11. So you'll have this data and you'll reuse it over and over and over. Well, 3 times. And really the only thing that the reason we say don't get a fun size bag or what, like you passed out the other night, is because this condition won't be met. And really we're talking about P hat for these, because we don't know. No, it could be either one. Depends on which problem you're doing. Okay, so are you all happy with well, let's do 5 minutes on this and see how you do. Set a timer for 5 minutes. Oh, I did set a timer. How we doing, everyone?
I'm ready.
All right, let's do it then. So as I said the other time, you should, I would encourage you to use the reference sheet as you work through these. So we're on 8.2, the central limit theorem for proportions. So the three things that we're trying to show is random, independence, and normal. And then probably the shape is going to be called from that. So what'd you all say for random?
It's given.
Yeah, it's given. Here it is. How about independent? Was that given?
No.
So how did you prove that the each student was independently drawn? Well, let's look at the how to show independence. It's either the observations are independent of each other. If the sample is collected with replacement, they're independent, but it doesn't say with replacement anywhere. It just says 100 students were gathered. So we have to assume that this has happened. It's been done without replacement. So to show that the observations are independent, we have to show that this is true. And I think we noted that this is a rare time that we're told the population size. So did you all write 100 is less than or equal to 0.05 times 7.8 million? And then just note, hey, that's good. You don't have to do that calculation.
I got the I switched the 100 and the 7.8 million.
Got you. So you
So
had
usually they don't give us the population size,
correct.
so we just
Most,
have to guess.
well, most often
Like
what
all.
go ahead. Yes, that's right. Yeah. What I want you to do if you aren't told the number would be to say all part-time students. And then just say, yep, that's true. Part-time college students. But this time we gave it to you because that might not that might not be obvious to anyone that 7.8 million is like I had no idea how many part-time college students. So this is a nice time that we gave you the 7.8 million. Cool, good. Sample size is always the n. So the formula, this is the same thing from 8.1, this little piece. So it's always sample size is less than or equal to that. And we have to give you this number, otherwise you can't do anything. Cool. How'd y'all do with normal? Let's see, what does it say? This is the one that most students mix up. A lot of times students are like, hey, this is awesome. 100 is greater than 30. Yep, we're good. No, that's only true for means. So the formula we've given you, or the little thing, the little inequality is n times p times q. But do you all remember what q is? Nice. Sorry. Good. Now you won't make that mistake anymore. So this is q is 1 minus p. I'm surprised. Oh, here it says it back here. So these p's and q's are the same thing from a binomial distribution. And when we work with a proportion, that's exactly what it is. It's a binomial distribution because either the the observation in the sample has the characteristic we're interested in, or it doesn't. So it becomes a disjoint outcomes. So we are going to do the 100 for the sample size times the 0.6 for the probability of success, meaning 60% of these students were female, times the 0.4. Let me actually write that, and that's how we calculate that. Times 1 minus 0.6, that's all the other students that are not female. And then we want that to be greater than or equal to 10. When you do your project, this is what you have to run to see if the amount of Skittles you have is large enough. And that's a little bit further down the road. So let's do it. 100 times 0.6 times 0.4. 24. Hooray, it did it. 24 is greater than or equal to 10. This is just given to you, right? It's just like, hey, this has to be true. I remember being shown why, but I don't remember what I was shown. So I can't tell you where this came from and why it has to be this. I'd have to look it up. If anyone is super interested, I will look it up and tell you the why. Someone tonight might ask me to do that, so maybe I should do it in advance. How we doing? That's the 3 conditions, and they're the same 3 conditions from 8.1, with the third one being different. And it's the one that's the easiest to mess up. Did you all do B and C? Anyone know what this is equal to? I'll give you a hint. It's right here.
So it's just the 7.8 billion.
Ooh, now the 7.8 billion is the capital N. What we're looking for is the P, which I didn't label. This is the P.
So it's 0.6. Okay.
That's it. Yep. So what's happening here is we're gathering a bunch of samples of size 100, and we're saying what percent or what proportion of those 100 students are female. That's a bunch of P hats. And so then we're going to generate this data set of P hats, all these different samples, size 100, with the proportion that are female. And we're saying if we added together all of those proportions, nice, yes. So, the connection between P and population is the word parameter. Now you have to think P is proportion. Just that's the tricky part. So if we added together all of these all of these different proportions and divided by how many, the mean of those proportions is going to equal the population mean. And this is the population mean. Now that's the other thing we have to be careful of, is there's a P hat, which is the sample mean, and there's a P, which is the population mean. Okay, then
Eric, if you look at the formula, maybe that would help her. It says mu of P hat equals P.
Right, and that's where I realized, yeah. So
And in this
P
case-
hat is the sample.
yes.
Yes.
Okay.
And we aren't given a P hat here. We don't know how many females in here were in this particular sample, how many females there were. We just know 60% of these 7.8 million part-time college students are female. How about this one? This is the other thing that's different. So if you think back to 8.1, it was just the mean of the sample means was the mean of the population. Down here, because we're working with proportions, the mean of the sample proportions is the population proportion. But then the standard error, which is now SE hat, as opposed to SE x bar, which is sigma x bar versus sigma p hat, is now the square root of p times q divided by n. And if we don't know the population values, we use the sample values, the p hat and the q hat, and get an approximation. We already know p and q from here. And I'll write that. So let's label this as p and we'll label this as q. And that's actually 0.4. So we're just going to do the square root of 0.6 times 0.4 divided by 100. I like to use Desmos for these types of questions. Um, 0.489897, blah, blah, blah. Let's do like 3 decimal places. 0.049.
I think it says
Lead
5.
5. 1, 2, 3, 4, 5. Okay, so there's the 5. There's a 9 after that, 8, so that becomes a 9. 4899.
I think my stat lab has them do 9 or 5. That's why I think.
Well, and that's really important for StatLab, because if you have to use these numbers to do a calculation later, and StatLab is super picky about being exactly,
Bless you.
excuse me, thank you, accurate, then you gotta have what they ask for. How y'all feeling? Who knows the 3 answers to D? Let me write this out symbolically, by the way, so we can see what's happening. Here they gave us a sample size n, which is the same from the problem above, and they said only 35 of the students in that sample were female. That's the x. That means we can calculate a p hat, which is 35 over 100, which is 0.35. That's way less than the 0.6 we were told is the population proportion. And so we're being told that the probability of a p hat being, boy, it really sounds like we're saying equal to 0.35 is what it sounds like, is this. That's super tiny. 1, 2, 3, 4, 5. 1, 2, 3 is this. I think we want to say less than or equal to this. So I don't think.
Yeah, I don't even, because like in StatCrunch, you only have the 2 options.
Right. This is a normal distribution, so being equal to is like impossible. So this, what are 3 conclusions, 3 explanations for this highly unlikely result? And if you're forgetting, I'll just put page 198 here if you want to just glance at that for a second. And write this on your reference sheet.
The fluke is one of them.
Good. Stuff happens. It's not 0.
The where it was a wrong proportion, or is that what it's
That's the right idea. The 0.6 is wrong. So that's
wrong
the
parameter?
And one other. The sample itself could be problematic. Biased
Oh, yeah.
sample. Nice. So if you've started your reference sheets and you haven't put this on there, put them on there. We could come up with some explanations. Like the best explanation I like for this one is just saying that the probability of a p-hat being less than or equal to this is not 0, so it could happen. I mean, it's like crazy unusual. The parameter could be like maybe now the military will only draft females, and we have a draft, and the males need to be left in the workforce, and they all need to be re-educated. So that's ridiculous because that's probably not going to happen. But something's happened that less female. Oh, you know what? COVID happened. This happened with COVID, right? And so now all the mothers are being stay-at-home moms because of COVID and probably having to work, and the men just work. Oh, that's like not anything new, is it? We'll just say something changed. And then the bias sample is, I don't know, what's a subset of society where only men go to school? Oh, it's the 1950s again. I don't know. Okay, let's move on. I'm gonna get myself in trouble. So let me give you 5 minutes to do this one. You probably don't need 5 minutes. How about 3? Or did you all do this one already? Because I kind of told you the answers.
So for p-hat, that it doesn't give us the p-hat.
What's the formula for it? I'll just write it. So you
I'm not sure.
it's that. Let me show you where to
Oh.
find it. Let me show you where to find it. In 8.2, it's buried. Where is it?
Yeah,
Is it?
Cindy said it yesterday. I remember now.
Oh, it's not on the reference sheet anywhere. I thought it used to be on here. Oh, okay. So, right. So you have to have that memorized, meaning write it somewhere on your reference sheet because it's not in this provided stuff anywhere. Maybe it comes later.
I had them write it on the bottom of that 8.2 page.
Write it on there, everyone. Yes. Oh, here it is in
Oh,
chapter
yeah.
9. But that's in chapter 9. So yeah, put it on that 8.2 thing. It's x divided by n. And so remember what that is. X is characteristic of interest. So from chapter 6, this is the success, what we define as success. And in this case, what we're defining as success is the number of Labrador retrievers. You didn't put your shirt on, sweet. And then n is the n we already know. It's the same n as before, sample size. So we kind of did that, right? This was 38. That's the number of dogs on this day. This is the 12. This is 12 divided by 38. And the author of this text, well, the person who wrote it, Alana Tuckey and her husband, they have Labrador retrievers. So they're biased. That's the dogs they like. I don't think you need the decimally, you don't need to write as a decimal. So what do you all think D is asking? What's the question in D? I think you're right. So let me talk through this one. So a statistician is telling her she needs to collect data from many more random days. Now, hi, Sarah, welcome. We're on page 641. So if we go back and look at 8.2, the many more place that shows up here is this word, large enough. We need a sample size that is large enough. And the way to determine large enough is this little inequality. Is the n times the p times the q greater than or equal to 10? Now, there's another, so this is a pretty complicated question, because then we have to get what the groomer is saying. She knows how much of her business is comprised of Labrador retrievers. This means she knows the population. That's her claim. She's inferring from this sample that 31% of all dogs, or 32% of all dogs that come into her business are Labrador retrievers. And I don't know a whole lot about dogs, but I'm guessing this means they're bigger, right? So you would have a certain type of equipment that you'd be using to groom these dogs as opposed to smaller dogs. So maybe you invest heavily in large dog grooming equipment, if that's different. So what D is getting at is to check the normal distribution. Is it really
So
normal?
she needs more days to have a more accurate representation.
Yes, to guarantee that the sample values that she collected here come from a normal population, or that if she continued to collect samples of size 38, she'd get a normal distribution of the proportions. That's it. So what we would do is say, check, is 38 times 12 divided by 38 times 1 minus 12. Now what I'm going to do is I'm going to say how many dogs were not Labrador retrievers. So I'm going to subtract the 12 from the 38 and get 26 over 38. And I'm going to see if that's greater than or equal to 10. Because what she's doing here, right? She's making an inference. She's inferring the population value from this sample value. And the only way that that could be accurate is if all three conditions are met. These three conditions. Now, randomly, I suppose how dogs walk into her business are somewhat random. I mean, we'll kind of ignore all those and just double check this one, because this one fails. So what I love about Desmos is you can just you can type the fractions in. You don't have to worry about any of that conversion stuff. I used to teach people how to mess with fractions in this class, and it's like not necessary when the technology does it. Look at that, 8.21. So her sample size is not large enough. Only 38 dogs doesn't guarantee. What we're saying is the sample proportions are not, let me try again. The sample, the distribution, this is what I want to say, the distribution of sample proportions, in other words, p hats. By the way, if you want to type things and you want to make p hat, spell it out, there's how you can do it, are not necessarily, oh, I love this, like it helps me spell the words and everything. And we need that condition to be true in order for this to say something about the population.
Could we say like the condition 3 does not work? Or
Yeah,
something
condition
like that.
3
Okay.
is not met. Yep, that works. Okay, let's practice some SEPs. That's what this is. Just hey, can you calculate these? So I will write the formula at the top. You all run the calculations real quick, make sure you're comfortable with it. You do have to, yeah, you really kind of have to put them in a calculator, because I don't know if you can put square roots in StatCrunch. Now, do you all like Q, or is Q distracting? Is it easier to think of it as P1 minus P all over N? We used
I
to
do
write.
not like Q.
Okay, so let's just not put Q in there, because it's just one more thing to remember. They used to have it in there as 1 minus P. It doesn't look as clean. You know, Q is a little bit neater. And then remember that if we don't have the P's, which we don't here, we have the P hats, we can use P hats as our approximation. And it's a pretty good approximation. That looks like a little face. If you look carefully at it, you know, there's the eyebrows and something. Okay, so let me give you like 3 minutes. Oh, you probably can do it in 1, especially if you use Desmos, and you get these calculations. All right, y'all get it? I'll type mine in Desmos. So maybe I should have shown you how to get that square root. You can type SQRT and Desmos like figures that out, or you can click the square root button. And then you can also hit the slash sign, like the division sign, whoop, and it creates a fraction right away, which is kind of nice. And then you can do your 0.34 and your parentheses 1 minus 0.34, except to make sure it's the right thing. And then what do we have? 200, was that the first one? And there it is. And then like if you're a fan of shortcuts, you can just do Control C and Control V, and you can get all of them listed out real fast, just like that.
The first one is 100, Eric, so
Well, that'll,
it's 200, 300, and a 100.
let's do them in order. 100, 200, 300. So is that what y'all had? How many decimal places were we required? 5 decimal places, because that's what StatCrunch wants. All right, we'll zoom back in a little. You can go away. There we go. So 1, 2, 3, 4, 5. So 04737. 04737. And then 1, 2, 3, 4, 5. Oh, there's a 6 after, so the 9 becomes a 0. So 0335. 0335. And if we want to help ourselves feel better, put the 0 at the end. You don't have to. Even StatCrunch won't mark you wrong for that. And then 1, 2, 3, 4, 5. Oh, like 1, 2, 3, 4, 5. There's a 9 after that 4, so this becomes a 5. So 02735. 02735. This becomes a basic skill, meaning you just need to be able to do this because you're going to be using these in calculations. So you need to, that's part of why that's here for practice. Like you got to type it up, get the numbers, and then you're going to use that to do things like this. What's the probability? Any questions on that? Formulas here. So you have to know the formula. We've been using 1 minus P instead of Q. They are the same thing. That's what this line says, but it's just one more step of keeping track. Okay, so let's do 5 minutes. Well, let's see. Can you identify the things you need to identify in number 4?
So Eric, the night class will want to use Q, just to let
Okay.
you know.
Okay. See what it is. Actually, let me change my question here. What are you being asked to do in 4A? What's the question, or what is the answer to this? And I think Reagan, I hate to like lean on you so much, so I'm going to go ahead and underline it because you've been the main answerer here, and I don't want you to feel all the pressure. This is the main question. Describe the sampling distribution. Now that's a command, not a question, right? So there's no question mark at the end, which makes it sometimes a little harder to find, but that's what this is. Then the sampling distribution of proportions is blah, blah, blah. So yeah, that's it. Nice. Yeah, Kayla, nice. Good, y'all. Okay, so we have to state these 3 things. So do that. That's awesome, Senna. Your dog is just getting at you. And then use those to answer these. So I'm going to give you 5 minutes to try this. By the way, this is the time that you need StatCrunch. So go ahead and get logged in there. I'm fairly certain I don't need to show you this, but I'm going to do it anyways. The calculator you're using is the normal calculator. It's been the same calculator all along. Even though a proportion can be treated as a binomial distribution, what we're doing here is not treated as that. this will sign in. Anyways, I'll set the timer for 5 minutes. You all crush this. Fill out your 3 things and then use the center and the spread to calculate the 2 probabilities. Is it just 2? Yeah, it's just 2. And then we'll do some more. Set a timer for 5 minutes.
Eric, can you scroll up real quick so I can check my answers for the top ones? Thanks.
All right, my timer just went off too. So let's see. What'd y'all say for the shape?
I did n times p times q, so I got 200. And tell me if I did this right. I changed the percent to a decimal, so I
Love
did
it.
0.2333, 0.233, yeah. And then 1 minus 0.233, and I got 46.367, which is greater than 10, so it is normal.
Love it. So you were proving that condition 3 was met. Now, don't feel bad about this. It says assume that the conditions are met.
Oh God.
What you did wasn't necessary.
Oh, so I could have just said normal. Oh,
Because the
okay.
conditions are met. Yeah, yeah. So we know it's approximately normal because of that statement. So that's one of the things to keep track of, is when are you being asked to prove the conditions are met, and when are you just being told to describe the sampling distribution of the p-hats. And I know the way I said that, it's like, oh, it just said describe the sampling distribution, so that's when you know, but it's not always that obvious. And I get that it becomes very easy to think, oh, I need to do the conditions. So is that helpful?
Yeah.
Last night we kind of figured out that with the where they want you to verify, so we kind of talked about the word verify means that you want to list your 3 conditions, because usually the word verify was we kind of figured that out. So verify means put down your 3 conditions, and the word describe means your shape, center, spread.
Yes, that is the most common language we use on the worksheets and exams. Love it. Yes, 100%. And then there's the one other type of question where we're like, hey, can you use the central limit theorem? Or like, is it appropriate to use the central limit theorem, which is what was said here? Is it appropriate? And usually when we say this, it's not appropriate. Like one of the conditions is not met. Let's see, let me show you an example of that question back from 8.2. But when that happens, it's also like a really small place to put your answer. So here's one of them. It says, explain whether or not it is appropriate to use the central limit theorem. And in this one, condition 3 fails. So that's the third thing that could happen when you're dealing with thinking, do you need the 3 conditions or the shape, center, spread? And so this one, the clue is, we're not saying verify, which when we say verify, it means they're met. You have to prove you know that the 3 conditions are met. Fun, right? Good old reading. Okay, so we've got the shape. What'd y'all say for the center?
.233.
Nailed it. Because we identified this as the P.
Yeah.
And then the spread is the annoying one. I think you don't have that.
That's like what we did for 3, right?
Yes.
Okay.
Now notice this says include work in symbols. Now there's no work for shape and center. There's nothing to do. For spread, the work that would be nice to see what you did is, what did you type in the calculator? So this times 1 minus that, or the Q, which Reagan, you told us that answer, but I don't remember it. I should know it, but whatever. And then the N, which was 200. And then what is this equal to? And it looks like so far we've consistently been using 5 decimal places for this. Oops. I don't know why I didn't choose the, I had the 200, but whatever. So 1, 2, 3, 4, 5. The number after the 9 is a 2, so we don't add 1 to the 9. And it's 02989. 0.02989. Awesome. How's everyone doing?
Good.
Nice, nice, nice. I like that thumbs up. Me too. My coffee's slowly kicking in. Okay, so I suspect that this is a challenging question because here we have an X. And whenever we're working with these types of things, well, this is tricky because we used X's way back in chapter 7. When we say, what's the probability we get a data value greater than this? And we put an X there. This is also what's in here. It's a capital X though, not a lowercase x. And then in chapter 7, we also used a Z here. And then in 8.1, we used an X bar. And then here, we're really using a probability of a P hat being, in this case, it says more than a particular number. And we can't put 50 there because P hats are probabilities. They're numbers between 0 and 1, or they can be treated as probabilities, even though they're also proportions of the data set. Like they're essentially the same thing. So does anyone know what to do with this 50?
Do we make it into a decimal or a percent or something?
How? You're nailing it, but how?
So that would be, it would be 50 over 100. So it'd be,
Why did you pick 100?
or over 1. I don't know.
So think back to P hat, what it's equal to. You're on the right track.
Okay.
You just got to put it all together. It's X over N.
X over N, yeah.
So what's our N in this scenario?
Oh, we're still on. Okay, so 200.
Nailed it. Nailed it.
So 50 over 200.
That's
Okay.
it. And you can leave it just like that. That's what's kind of cool about this. Now, what is the mean for this problem? What are we going to put into our StatCrunch calculator for the mean?
0.233.
You were on fire. Does that feel good to be burning?
Yeah.
Yeah, it does. Love it. Love it. And then here,
The
we can just
spread
put,
is the standard deviation.
yes.
Okay.
The answer for spread is the standard deviation. That's why we use this symbol. We call it the standard error of the sample proportions, but it's really just a standard deviation.
Okay.
And then in here, you can type that fraction 50 over 200 if you want. Now, if you prefer, we could go over to Desmos and do 50 over 200 and get that decimal. It's 0.25. So we could also write 0.25 if that feels better. This is the problem that most students get wrong on the exam. Because watch, if I put 50 in here, watch what happens. It's 1. What?
So Eric, you want to change the direction.
Oh, yes, it's supposed to be more than. Thank you. I was getting it wrong anyways.
Wait, I missed that. Why did you change it to 0.25?
Oh, I'm sorry. So that's just
Oh, got it. Yeah, that
if
makes
you don't want to
sense.
mess with that.
Okay.
Either way is fine. Yeah. Ooh. Oh, it ripped a little. I'm sorry, JB. There's another one in the other box. Okay. Y'all remember what a percentile is? And how that compares to a quartile and how the two are different?
So it's 15 and below,
Oh,
or
man.
15% and below.
Like I'm getting burnt over here. It's like crazy. Good job. So we're saying less than this number is equal to 0.15. So we change this to less than, we put in 0.15, compute, there it is. Now, with p hats, these values look like areas. So you have to be very careful with sample proportions because you're always going to get a number between 0 and 1. Always for this. So just keep, maybe put a little note on that and be like, I need to keep track of, this is an x-axis value, although we've relabeled the x-axis as a p hat axis. So everything down here is a percent, which is just like everything up here, which are percents. So it's a very like confusing mix, easy to screw up or easy to mix up thing here. Awesome. Can I get in there? Sure. Okay, so we've done essentially every problem that you're going to face on the midterm. I mean, the final. So let's do like the exact one you're going to face. So you're done with the 033. This is the one you submit to Cindy by Sunday, 11/6. And just remember that for what Cindy sent you all, 10 is really equal to 11. It's nice that you finally messed up once, Cindy, because that's always me.
I told you you're rubbing off on me. Eric.
I know, this is so bad. Let's come back to number 1. I want to do the problem. I want you to do problem 4 because this is the exact problem on the final exam. And part of what's going to happen on the final exam is it could be a proportion or it could be a mean. And remember that just changes slightly. The only difference is condition 3 and how we calculate the spread. Those are the only different things between the mean and the proportion. And it's the ones that everyone gets wrong. Too often I see n greater than 30 here, and too often I see something else. So these are the two that get mixed up. It makes sense, right? Because they're the two that are different. So let me give you 5 minutes and see if you can't get A and B. It's very similar to what we just did. If you can do it with 0 help, you're ready. Let's do it. Let's go take the final. Well, we're not ready for that yet, but okay. So 5 minutes. Set a timer for 5 minutes. Okay, that was 5 minutes. How did you answer A, or are you all stuck?
Since it says verify, that's when you do you list the conditions.
Oh, yes, that feels good. Okay, okay, good. So maybe maybe I should do what I usually do, or what I haven't done in a long time, and highlight how to read this. Sounds like you're good. So according to this 2018 Vox poll, don't care, not helpful. 45% of Americans report watching the Super Bowl yearly. What do we think? Is this a P or a P hat?
P hat, because it's like the percent of the whole thing.
I'm gonna say it's the opposite for the reason you said. When you say whole thing, you
It's
are saying
Out of the proportion. Oh, okay, got it.
because it's all, and the word all
Okay.
is missing, but it's implied right here. Of Americans implies all Americans. They're watching the Super Bowl. And then this one's the simpler one. This is the 120 pulled from this population. Excellent. So condition 1, random, given, blah, 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 right? Always given. In case you're wondering, really, was it given? Yes, here it is. Condition 2, independence. That's the tough one, right? We have 120 people we talked to. Is that less than or equal to 0.05 of all Americans? Yes, definitely, right? Easy, all Americans. And then the one that we often mess up. How do we know then that we're going to have a normal distribution for the sample proportions? Well, 120 times 0.45 times 1 minus 0.45 has got to be greater than or equal to 10. That's what we're interested in. I'm doing this for you all. I'm assuming you all have done it. 29.7. Is this feeling good, everyone?
Okay, for some reason, I did that one was the P times the square root of P times Q over N. That's for spread.
Yes.
Okay.
Awesome. Yep. Easy. Like it's for the same. It's not for the same thing, but it's easy to mix those two up because there's this one versus this one.
They're both like the third thing.
Yes.
So Reagan, like if you need to have those like that page right in front of you when you do it,
Yeah.
feel free. Like
Yeah.
you don't have to memorize. This is in your exam notepad.
I was looking back and I think I just looked at the third. I was looking at like the spread because it was the third one when I should have been looking at like the
Condition
one that
3.
had the conditions. Yeah.
Yep. So easy to do.
Right, because we've said all these things are true, we now get to describe the distribution. Love it. Shape, center, spread. It's approximately normal. Now, if you just write normal, I'm not going to take off points. I'm always going to write approximately normal because it's always approximately normal. It's never necessarily guaranteed exactly normal. And that's like real world math is messy. Like everything you were taught in high school, mathematics, it was all neat and clean and perfect, and you did all these things and not very many decimals, and that's not at all what happens in the real world, which is statisticians are real good at that. Talk to me.
So for shape, it's the same thing as condition 3.
Because condition 3 guarantees that we'll have a normal distribution of the sample statistic. It's like we're just restating it. We're just like,
so,
yep.
But they use like the same things to find the shape. You do the same as for condition 3.
Well, what you're doing for the describe the distribution is you're stating the results. This is the Y.
Okay.
And this is the results of that Y. So you
'Cause-
don't need to show any work or anything. You're just going to say it's approximately normal.
You could say because of condition 3.
There you go.
You could just
Got
say
it.
normal because of condition 3.
But you don't have to do that work that,
No, you already did
okay,
it.
got it.
You did
But it
Once-
does use the, like the same thing, but
Yes.
it's just don't have to do that. Got it.
That's why it's approximately normal. We're talking about the same thing here. Because down here, we're saying the shape of the sample proportions is going to be normal. And down here, we're saying, will the shape of the sample proportions be normal? Yes, it will if our sample size is big enough. So yeah, you're right. Those two are connected. I do want to see you write mu p hat here. So the mean of the proportions, and that's always equal to whatever was stated for P. In this case is 0.45. You don't have to put the 0, but the nursing department wants you to. And then the spread is I do want to see the symbol either sigma p hat or the SE parentheses p hat, either one. And then this is where you now have to do that square root mess. And I hope you're all okay if I just put in 0.55. That's the result of this. And then what was our sample size? 120. And we're consistent here. That's nice. We want another 5 decimal places. One, 2, 3, 4, 5. So the number after the 1 is a 4. Be careful. Some of you might be tempted to say, oh, look, that 4 rounds to a 5 because of the 7. And so then since that became a 5, now we can round the 1 to a 2. That's rounding twice. Don't do that. Just note that the number after the 1 is a 4. And so our result is 04541. Yeah, how happy are we?
Feels good.
Yes, good. I know some of you will trust me when I say this is the final exam question. This is what it will look like. A prompt. Verify you can do it. Tell me the distribution. Now do some calculations. So these 4 calculations, these 4 questions are based off of what we just did. It might be helpful to write at the top of the page, mu of p hat is 0.45. That's what you need in StatCrunch. The spread or the standard deviation is 0.04541. Be careful in StatCrunch. What you put inside here has to be a number between 0 and 1 when you're working with a proportion. Especially because we're doing a mean of 0.45 and a standard deviation of 0.04541. So if you're given a percentage, convert it to a decimal, always and forever. All right, so let me give you 5 minutes and you all see if you can't get through these. Be careful of where it says X. Think carefully about what to do with that. Okay, 5 minutes. Set a timer for 5 minutes. That was 5 minutes. Y'all had enough time, or do you need more?
I'm ready.
Okay, let's do it. So for the between 0.41, 0.46, compute. Does that feel good? Oh, look at that stinky 5 after the 9. Somebody's a little bit annoying. 0.80. Yeah. Just in case you put in this, see what happens? It says 0 because I forgot to put the decimals in. So just be aware that you can get numbers that, if you're not thinking carefully, are definitely wrong. Fail. But you'll still get a result. Okay, 10% chance that the sample proportion of Americans who watch Super Bowl yearly in a sample size of 120 will be at or below such and thus. All right. Keyword at or below. I'm going to write this in symbolic notation. At or below is less than, and we're wanting that to be 0.10.
Do you want us to write out what we put in, or are you okay if we just write the answers?
Well, that's a really good question. It does explicitly say
Okay.
state that notation.
Okay. Well,
Um,
for C, we can't really write anything.
ooh,
But for B.
you can. It's tricksy. So like I like giving people freedom to do whatever, but I think it's super helpful. If you can write this correctly, you should be able to get the right answer. And it's
Okay,
a great way
yeah.
to check. That's my argument for why.
Got it.
It would also be beneficial if you did get the wrong answer, that Eric could give you partial credit
Yeah.
on the final if he saw that you just messed up and put something in wrong. Like put the wrong direction or something.
Yeah.
Yeah, that's the more important one. I like giving partial credit, but if all I see is an answer, I can't. So this one, what you're putting in there is less than or equal to 36 out of 120. Ooh, tiny. 1, 2, 3, 4. You don't even see any area because it's so small. It's like, that's 0, right? Essentially. So is it unusual?
Yes, it's 0.05%, which is less than 5%.
Good, yes. Why? Because this is a bunch smaller than this. Good, good. When it says explain using probability, that's what we mean. This statement is the explanation using probability, because this number is the, what you might call the fence line for unusual. Okay, I'm curious. How did you all answer F?
Fluke, bias parameter, and bad parameter.
Oh my goodness, that's so good. Wonderful. Although this color green is ridiculous for watching. So for the rest of you, if you're here, I'm just wondering if you're here. Totally fine if you're not. But I want to take the temperature of you. I know how Reagan is doing. She's crushing it. How are you all doing? Anyone have questions? Anyone concerned? Do you have these 3 things in your reference sheet? Anyone completely lost? Because I could be a really bad stats professor, and I could say, because the one student who's talking knows it all, therefore all of you know it. And that's really bad, a really bad inference, but we do that all the time. Okay. Nice, Kayla. I like hearing that. All but E. Do you know what got you? Oh, baby. Oh, bro. Do you know what got this wrong for you on E? Did you figure out? I'll help you. Yeah, the fraction part. Good. That's a really common thing. You might even want to put a note in your reference sheet that says, hey, with the proportions, when we're given X, write it as a fraction, right? P hat equals X over N. Easy to like forget that little piece. Okay, so that's the big final exam question. There's still a few questions left on this worksheet to do. And honestly, they're a little bit tricky, but let's go back to number 1. And let's see if you remember the connection between the sample size and the shape. So I'll give you 5 minutes to do this. Pay close attention to what this says. And think carefully about what it means to compute standard error. Like, what are you being asked to do? And what do we mean by center? Hint, look at the describe the distribution part to answer that. So 5 minutes, maybe it's too much. When you're done, just tell me I'm done. Let's talk. Set a timer for 5 minutes. Okay, y'all, how we doing? Turn off the timer. I'm gonna write the explanation first.
Just got done. I think.
Oh, I rushed you. I'm sorry. Did you think this?
Yeah. So
Nice.
as, yeah, I wrote, so as the sample size goes up, the spread goes down.
Nailed it.
Same diff.
Same thing. Yours costed a little more ink,
Yeah.
so sorry. That was a higher investment, but sample size spread. Yes, excellent. Boy, but it's a little tricky to tell which is which. So what went where? We have a 10, a 20, and a 30. This is page 643. Nice. Kayla, I'm going to agree with you on that this is 40. I
For
agree.
B, I said 10,
Yeah, I would agree with that too.
and then 20 for C.
20 for this. Some people wrote the words, but it's easier to grade when you say the numbers. Love it. What was the center for all three? Which I don't know if I totally agree with this statement, but
I put 0.6, but now I think it might be 0.65.
you
Yep.
think right the second time. Good. Yeah, what we're really asking is this. And without, like, we could check to see if it was guaranteed. I'm going to guess that if we did N times P times Q for all of these, this condition wouldn't be met for maybe B and C.
Mhm.
There's a good chance, but we'll just let it lie. If you look at them, 0.65 is roughly in the center of all of the distributions. Okay, so for C, you used this formula, right? Square root of P
Q.
Q N, but then the largest spread. Which one has the largest spread?
B.
Good. So think through, if the smaller you divide by, the larger the number, the fraction is going to be. That's another way to keep track of that. Oh yeah, this is definitely going to have the most spread because it has the smallest divisor. Love it, Kayla. Let's see, 0.65 minus 1 is 0.3. Excellent, y'all. Is it feeling better? Maybe it was never bad, and that's good too. Nice, sweets. 0.150, oh, 5. 1, 2, 3, 4, 5. 15,083. Okay. Let's see, two more little problems. I think let's talk through number 3. Number 2 is just compute this, right? Like, bleh. That's just what we just did. Repeat, rinse, do it again. But number 3 is a little bit of a weird one. We're studying like streaming services, that growth, like Netflix, and there's a million of them now, Disney Plus and Hulu and HBO minus and whatever else. So they get a sample size of N equals 30 Americans, and ask them, what do they watch? So if 60% of all adult Americans watch streaming services, what is this 60%? P hat or P?
It's 60% of the whole thing, so it'd be P.
Love it. Okay, so we know this. How many more adults does researcher need to sample in order to ensure the sampling distribution is normally distributed? What? So we're being told that this is too small. We could prove that to ourselves by doing 30 times 0.6 times 0.4 and see, is that greater than or equal to 10? Like that's, we're being told that this fails.
So that's 7.2.
Oh, thank you, 7.2. Oops. Okay. So oh, is that, yeah. So what we can do then is say, all right, let's ignore the 30 for a second and let's write an equation. N times P times Q. And let's solve for N. So here's where you do a little bit of algebra. If I do 0.6 times 0.4, you all correct me if I'm wrong. Isn't 6 times 4, 24, and then we have 2 decimal places, so we move it 2 places to the left. So we'd have 0.24 times n greater than or equal to 10. So I'm just multiplying these two together to get that number. Does that feel okay?
So you did 0.6 times 4. Oh, so n times 0.24.
Right.
And you haven't done that yet. So times 30.
Why don't I? Well, so I'm taking out the, so over here, this is just 7.2. 30 times 0.6 times 0.4. So that fails. And so we need to up our n. We need to get it larger. So let's just figure out what should we.
What should n be?
And then, so, right, I'm solving this.
Okay, got it.
Is that okay to write it? Maybe I should write it.
Yeah, that makes more sense. I just didn't.
Keep the order the same order it's showing up in the inequality. So these two equal that. And then to undo multiplication, we're going to divide. So we need an n greater than or equal to whatever this result is. $41.666667. So we need 42. You're going to find in chapter 9, section 9.4, that when we're determining the minimum sample size, we always round up. So this one you needed to round anyways because there's a 6 after the 1, but we'll talk about that a little later. So this is the smallest sample size that guarantees a normally distributed sampling, a sample distribution that's normal. So how many more do we need?
So we need 12 more.
Nailed it. 12.
That's the answer.
That's the answer. Woo!
We did one in the notes like this yesterday. Unfortunately, it was the very first example.
Yeah,
Do you remember that, Reagan?
not a good start.
Yeah, I said this is not a good start, guys, but
Yeah,
You're not going to be asked this on the final exam either.
I told them they probably would not see it.
Yeah. Just here. Okay. Here's what I'd like to do for the last 12 minutes of class. I want to go to the chapter 8.
do we have to do 2 still?
Yes.
Okay,
So just do that computation.
okay,
Right?
got it.
I kind of skipped it because I'm like, so let's go to the chapter 8 review. We don't have time to work on it. But what I want to do is you all turn your mics off and we're just going to look at it and we're going to say mean or proportion. That's it. So number 1, does this problem deal with means or proportions? Or you can type it in the chat if you don't want to mic it.
So I think he meant to turn your mics on, not turn your mics off.
Oh, yes. Yeah.
Well, it says population, so probably proportion.
Well, you know what? There's a population in either one.
Okay.
So I'm going to circle a word.
Mean, yeah.
Okay. No worries. This is what we're practicing. We're getting to be comfortable with that. Okay. It's a mean. So it's a thing from 8.1. Okay. Number 2, are we working with a mean or a proportion? Good. How do we know it's a mean, though? I'll circle it right here. We're given a mean and a standard deviation, and these numbers are greater than 0 and 1, so these are not proportions. But okay, so this is a problem dealing with a mean, so you're going to use your 8-1 stuff. All right.
So if
Number
it
3.
has that table, that doesn't automatically mean that we're using it?
Yeah,
or-
not necessarily.
Okay,
Except that when you look at what this mean, because we could have a mean here that's of sample proportions,
okay,
and we
okay.
could have a standard deviation. So this could be a mu p hat and a sigma p hat. But typically when we give you this, it's a mean that you're working with. That's the sample statistic. Okay, how about number 3? Mean or proportion?
It has the p hat, so
Nailed
proportion.
it. Good proportion. I'll shorthand prop. Okay, number 4, mean or proportion?
It's it's the mean because, oh wait. Well, it's a sample of 56 and it's not like, never mind.
It's a
Because
tricky
usually
one. Yeah, it doesn't say it
Yeah.
anywhere. What is this?
the percent, so it'd be proportion.
Good. This is the exact same problem we just did, where it says how many more do we need in our sample to ensure that it's normally distributed. But this same problem could be done with a mean. It's just the only criteria for a mean is that the sample size is greater than 30. So it's not a very interesting problem. You just look at the sample size and figure out how many more would you need. But with a proportion, it has to meet this n times p times q greater than or equal to 10 part. So this is what you're doing on this problem. But it's awesome that you noted anytime you see a percentage as related to a population or a sample, we're talking about a proportion. How about number 5? Mean or proportion, and how do we know?
It's a percent, so it's a proportion.
Good. So percent says proportion, and it says proportion in A. So that's another clue that sometimes the prompts aren't 100% like clear. They don't state it, but then down in the question parts, you get to see it. So it says it in A, it also says it in B. And then if you look at C, no, that doesn't help at all. But C has a percentage here. This could be anything, so that's not helpful because we use percentiles with means. Yeah, means would be using X bars, but this doesn't have any symbolic notation in here. Means don't use X's in this way. So for E, we have X over N. Okay, awesome. How about number 6? Mean or proportion? And how do we know?
It says standard deviation, so I'm gonna guess mean, an average, so mean.
Good. Look at A.
Good, Kayla.
Yep. Most often we say exactly what it is, at least for the chapter 8 stuff, somewhere in the question. Here's 2 places it's saying that. Let's see, do we have any symbolic language here? We don't. If these are going to be written with things like P, X bar, something. Now here's a thing that's going to mess you up. Look at this. Oh no, a percentage. But look at the word that comes after it. 85% chance. That means probability. And with means, all of the probabilities are percentages. So just that's one other layer of complexity, is keeping track of, is the percentage a probability like it is there, or is the percent. So here's another case that it's a probability, but we said the word proportion up here. And then way back here, this percentage is not a probability, although we could treat it as one. It's a percent of high school seniors. Okay, so now you know all of the sampling statistics that you're working with in each of these problems, meaning you know whether you're looking at the central limit for proportions stuff or the central limit for means stuff. Put a note somewhere in your reference sheet or in your brain or wherever that when you're working with these 2 things, the only thing that's different is condition 3 and spread. That's the only difference between the 2. Everything else is the same. So your job to prep for the final exam is to get through this worksheet, do the whole thing. Cindy said she'll take questions tomorrow. Not please solve this problem for me, but my answer for question 1, the first sample, I put down 10. Is that right? Here's what I was thinking, kind of thing. And then I'm also happy to look at this on Monday as well. Start class Monday with questions on this. If you're the type that can't stand turning in things late and want to ask questions on Monday, we can move the due date to the next day if needed be, or like next Sunday. So questions, concerns, thoughts? Get excited because we're about to start chapter 9, 10, 11, which are the most exciting chapters. It's the whole, we've been building to this moment where we're finally going to do what we've been talking about. Take a sample and infer something about the population. We've made it. It's complicated, but you will be just fine. All right. I'm going to head off to my next class. You all are going to head off to your push-ups, and Cindy's going to start chapter 9 tomorrow, right?
I will.
Woo.
Bye,
Bye,
Reagan.
everyone. Great work.
See you tonight, Eric.
Sounds good.